In this video, we're going to look at trigonometric graphs and involving their transformations. So what we're going to do is take the first trig graph known as the Sine X graph. So we have a shape like this and it comes down like a wave. And then what we say is that the maximum of this graph is at 1 and the minimum is at -1. So they have certain values that crosses the x-axis. So it has a maximum of 90, so sine of 90 is 1, and then it cuts the x-axis at 180 degrees. This is 270 degrees, and this is going to be 360 degrees. Now this graph is known as y equals sine x. The next graph we're going to look at is the y equals cos x graph, and it looks like this. So with this graph, it has again a maximum at 1 and a minimum of -1 on the y-axis, and then the key thing here is it cuts at 90, so cos of 90 is 0. Then we get cos of 180 degrees is -1. We get 270 here, and then this value is 360 degrees. So this is the graph of y equals cos x. One of the other graphs that you need to know is something called the graph of tan x. So what is special about this graph? It has something called asymptotes, and they're basically boundaries of the graph. And it has an asymptote at 90 degrees, this dotted line, it's called an asymptote, and an asymptote again at 270. And the shape of this graph looks like this. So it comes quite really close to the boundary or the asymptote, but it never touches it. Then here it behaves like this, and then is towards 360. Now this graph is known as y equals tan of x. So now we're going to look at some transformations of trigonometric graphs. So I'm going to start off by drawing the sine graph in general. So we know this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees. And we know it has a maximum at 1 and a minimum at -1. So if I wanted to draw the graph, so this is the graph of y equals sine x. Now if they asked me to draw the graph of y equals to 2 sine x, now this resembles the function 2 times fx, or y equals 2 times fx. And we know the rule for this. You multiply the y coordinates by 2. So in our case, our function gets stretched by 2 in the y direction, comes down. So this would be 2, and this would be -2, and this would be the function 2 times sine x. The next type of transformation is to do the same thing for sine of 2 of x. So we want to draw sine of 2 of x. So what we do here, we draw one sine curve. Then what we do, we draw another sine curve. So I'm going to draw it in another color. Then what happens is y stays the same, as in 1 and -1. But we halve, so we know the rule for this, for y equal to f of 2 of x. We divide all the x coordinates by 2. So we divide x coordinates, the x coordinates by 2. So they basically get halved. So we know normally it has a maximum at 90, so we half that, so we get 45, and we just keep on adding 45, so we get 90, 135 degrees, 180 degrees, 225 degrees, 270 degrees, 315 degrees, and then finishing off at 360 degrees. Now this is the graph. All of it is y equals sine 2 of x. Okay, here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So you've been given the graph of y equals cos x, and you want to sketch y equals 2 times cos x. So we know the rule for this. This resembles y equals 2 times fx. So in our case, stretch it to 2, down to -2, and our graph goes like this.